What mass of glycerin, a non-electrolyte, must be dissolved in 200 grams water to give a solution with a freezing point of negative 1.50 degrees Celsius? In solving this type of problem, we need to think not only about what equation are we using to solve it because of what variables we have, we also need to be thinking about units, and most importantly, this I, that Van Hoff factor. Now, it's not a problem in this problem because we know that the I for a non-electrolyte is equal to 1. And so if you take 1 and multiply it by anything, you're going to get the anything right back. And so for this problem, you don't have to worry about I. But if it's a salt, it's going to break apart in solution, and you're going to have an expected and an observed I that you probably should look up in a table. First, you should think about and decide how many are going to probably be produced, but then you could also theoretically look it up in a table to find out what it actually is after all that ion pairing happens, and what you would expect and how it's different. But for this problem, it's a non-electrolyte, and we're just asking the question, how much of a mass of glycerin am I going to have to dissolve into my solvent, which is 200 grams of water, in order to have a freezing point depression of negative 1.50 degrees Celsius. And so when we're doing this problem, then we've got change in temperature equals my Kf and then my molality. And so in this case, my I is 1, so I'm just leaving it out of the problem. First step, first variable, change in temperature. How much are we changing the temperature? If we do this and we put negative 1.5 into my equation, I'm going to end up with a negative mass. That doesn't make sense. We're assuming it's going to be freezing point depression. So we're assuming we're lowering it. And we're lowering it by 1.50 degrees. The freezing point of water is 0 degrees. So what is my change that I'm expecting to see? I'm expecting to see a change of 1.50 degrees Celsius. Now, is that the right unit, or do we need to convert it to Kelvin? Degrees Celsius, look at my constant, it is also degrees Celsius. So we need it in degrees Celsius. Equals my Kf, 1.86 degrees Celsius times kilograms per mole. All that is now multiplied times my molality. So if we plug this into our calculator and we solve for our molality, we get 1.5 divided by 1.86. We get 0.80645 molal. What is molal again? Molal is moles of your solute divided by kilograms of your solvent. That already tells us how we need to figure out and solve and finish this problem. So if we have 0.80645 moles of my glycerin per kilogram of water, we can convert that right now from moles of glycerin to grams of glycerin. And that's per kilogram of water. So how do we eliminate or get rid of the kilogram on the bottom? We can multiply by the number of kilograms we have. So let's do that. Here, moles of glycerin. So if I want to cancel out my moles, I would put grams on top. What grams? Your molar mass, your molecular weight. And so that is 92.09 grams. That's my molecular weight of my glycerin. So after we multiply it by the molar mass, we're going to have grams, which is what we want. But that's grams per a whole kilogram of water. We don't have a whole kilogram. We have 0.2 kilograms. So I'm going to multiply that next, 0.2 kilograms on top. And if I plug all that in, I'm going to end up with my kilograms are going to cancel, my moles are going to cancel, and I'm left with grams, which is what I'm trying to solve for. Now, the thing I see students sometimes getting confused about is if you put an M here, this little m is mass. This little m here is molal, and so you got to make sure you keep those straight. Sometimes I'll put a little curly Q on the end of my m, just so it kind of helps me see that there's a difference between my mass and my molal. So what is my final answer? We end up with 14.9 grams of glycerin. What that means is if I place 14.9 grams of glycerin into 200 grams of water, I'm going to lower the freezing point of that solution by 1.5 degrees compared to my pure solvent, which is water. And so that's how you solve these types of problems. The only difference is if you have a salt, you have to take into account its Van Hoff factor, which is going to tell you for every 1 mole of solute, how many moles of each of your total ions are going to be produced.